Hi guys, what's up? Welcome back to my CapMath tutorial channel. Daniel's here and today I'm making my first video in statistics. So as promised, my first topic will be talking about some basic ideas of statistics. And in the basics idea of statistics, I have 5 main points. The first point is some basic concept in statistics. The second point is sampling how to collect a symbol. Uh, the next point is types of data, how to define the variables. The next point is design of experiment, and the last one is bias of study. At first I wanted to combine all of these together into one single video, but then I realized it might be time consuming, it might be long, because all of these together might take up to a few hours to get it done. So it might be very tiring for people to watch my video, and also it makes me tired as well. So I have decided to divide my video into 3 smaller videos. So the video today, I would like to talk about the first 2 main points, the basic concept and sampling. Then the second video, which is coming next week, will be talking about types of data, and the last video of this topic will be talking about design of experiments and bias of study. So now let's get started. In basic concepts, you want to learn statistics. So the first thing you need to know is, what is statistics? So what is statistics? Statistics is the study of procedures for collecting, describing, and drawing conclusions from information. And to understand better this idea, I would like to go over a very simple example. Suppose you wonder what is the average height of students in your college, and assume that your college consists of around 10,000 students. 10,000 students, 10,000 is a very big number. You cannot go to one by one student, like each student, to ask about their height. So it's almost impossible to collect the heights of all students from your college. In this situation, the better idea is you collect the information from a smaller sample, a smaller group of students from your college. So, for example, you go to 100 students in your college or 200 students from your college and ask about their height to collect information. So after you collect information, you will calculate the average of your the average height of the group of 100 student collected, and then make conclusion for the average height of student from your college. So that's how you make statistics. First collect data, then describe the data, and finally from the data sets draw a conclusion about the population. And in this situation, your question of interest is, what is the average height of students from your college? So you are interested in the group of all students from your college. So in this case, all students from your college make up a population. And the group of 100 students that you survey, the group of 100 students that actually were surveyed is a sample. And the average height of all students from your college, which is the thing that you are interested in, is a parameter. And the average height of 100 students from your college is a statistic. So let's go over the basic concepts. Here, just by the first example, a A population is the entire collection of individuals about which information is sought. A symbol is a subset of a population containing the individuals that are actually observed. A statistic is a number that describes a symbol, and a parameter is a number that describes a population. And one more thing, when you collect the data, the process of collecting the data is called sampling. And when you want to collect a data, you have many ways to collect a data. For example, you use computer to run randomly 100 student IDs and go to those 100 students to collect their height. So in that situation, you have one symbol. Another way is you go and collect 50 students from College of Science and 50 students from musical department and put them all together to make up a sample of 100 students. So you see, we have many methods to construct a symbol, to collect a symbol. Today, I would like to go over 6 basic sampling methods, 6 basic methods to collect a symbol. The first method is called symbol random sampling. The second one is symbols of convenience. The next one is stratified symbol, cluster symbol, systematic symbol, and the last one is voluntary free response symbol. So now let's look at the first sampling method, symbol random symbol. The basic idea of symbol random symbol is just think about lottery. You see, like when you read the name of this sampling method, symbol random symbol, so there's one thing you have to guarantee, that is randomness. So think about a lottery game. Suppose 100 lottery tickets have been sold, and your job is choosing 5 winners. You know, in the lottery game, we expect fairness, we expect equality, we expect fairness, because if the game is not fair, you're not gonna play that game. For example, if the game just collect winners from only women or the winners from only men, then the game is not fair. So the property of a lottery game is that we care about randomness and fairness. So what is the fairest way to choose the winners in this situation? The best solution is we put the 10,000 tickets in a drum, mix them thoroughly, and then draw 5 tickets out of them one by one. Like you withdraw the first tickets randomly, and then continue to withdraw the second tickets, and then the next one until we have enough 5 tickets. So that's how you choose 5 winners from the lottery game. So the idea of symbol random symbol is just the same. Here you see that each ticket is equal likely to be one of the 5 tickets drawn. For example, if I label the 10,000 lottery tickets by number from 1 to 10,000, the probability, the chance of getting the ticket number 96 should be the same with the probability, the chance of getting the tickets number 102, for example. And one more thing, each possible collection of 5 tickets is equally likely to be drawn. For example, the probability of getting the 5 number 5, 6, 9, 18, 93 should be the same as the probability of getting the group of 5 number 120, 196, 252, 977, and 845. So the chance of getting any group of 5 numbers should be the same. So that is the property of a lottery game, and is also the property of symbol random symbol. So definition: a symbol random symbol of psi n is a symbol chosen by a method in which its collection of n population items is equally likely to make up the symbol, just as in a lottery game. So let's check your understanding. Let's look at this situation. A pollster wants to estimate the proportion of voters in a certain town who are Democrats. He goes to a large shopping mall and approaches people to ask whether they are Democrats. Is this a symbol random symbol? Here, what we need to check is randomness. Since the pollster goes to a large shopping mall and approaches people to ask about their opinion about Democrats. So this is not a symbol random symbol, because this symbol collects only people who go to the mall. So answer no, this symbol consists of only people in town who visit the mall. The second situation: a telephone company wants to estimate the proportion of customers who are satisfied with their service. They use a computer to generate a list of random phone numbers and call those people to ask them whether they are satisfied. Is this a symbol random symbol? So in this situation, the investigator used a computer to generate a list of random number. So this is how we make up a symbol random symbol, just like a lottery game. Assuming that all customers who are called will pick up the phone and answer the question. So in this case, it is a symbol random symbol. So the answer is yes. Every group of n customer where n is the sample size is equally likely to be chosen. So that is about symbol random symbol. Now we go to the second type symbol. You know, symbol random symbol is the best symbol when we collect data. However, sometimes we cannot collect a symbol random symbol. There are some situations that is very difficult and also might be even impossible to collect a symbol that is truly random. Let's look at some example here. So the idea of symbol of convenience is just basically make it convenient. Let's look at this example. Suppose you are interested in the average GPA of students from your college. So if you want to collect a symbol random symbol, what you have to do is use your computer, generate a list of 100 students from the list of student IDs, and then go to these 100 students to collect their GPA. However, sometimes it's really hard to have enough the list of all student ID to generate the list of 100 students. And also, when you approach someone to ask about their GPA, they might not review you about their GPA. So in this situation, it's not easy to collect a symbol random symbol. So for convenience, you might go to the people who surround you to ask about their GPA. So instead of running a symbol random symbol, you just go collect information from people who are in your circle. For example, your best friends, your classmates, your friends of friends, and ask about their GPA. So in this case, you are making a symbol of convenience because it is convenient. However, there is an issue. Suppose you surround yourself with only smart people because, for example, if you are smart, you just make friends with only smart people. Then when you go and collect the data, the group of people, like 100 people, inevitably you collect a symbol of all smart people. So like the GPA, it might be the case that all of just your friends have high GPA. So in this case, your symbol cannot be the best representation for uh, the whole population. Another situation, a construction engineer had just received a shipment of 100 concrete blocks. Is weighing approximately 50 pounds. The blocks have been delivered in a large pile. The engineer wishes to investigate the crushing trend of the blocks by measuring the trends in a symbol of 10 blocks. So in this situation, if you want to collect a random symbol, you really have to remove the blocks and remove the blocks to collect the 1,000 blocks to collect the 10 blocks randomly. But it's very hard for the engineer. Like removing the blocks is not easy. So in this case, it's difficult to draw a random symbol. So instead of drawing a random symbol, we think about symbol of convenience. So question 1, why it might be difficult to draw a random symbol of blocks? The answer is to draw a random symbol would require removing blocks from the center and the bottom of the pile, which might be quite difficult. The second question, how the engineer might draw a symbol of convenience. So in this case, the best way is like the engineer will take 10 blocks off the top of the pile. So he doesn't need to remove so many blocks. So in this case, he created a symbol of convenience. So symbol of convenience. Definition: a symbol of convenience is a symbol that is not drawn by a well-defined random method. In a general speaking way, it's like a symbol that is drawn by a very convenient way, like go to very like make it very convenient, make it very easy. So the disadvantages here is that a symbol of convenience is not always acceptable. For example, if you look back to the example of the engineer removing blocks, a symbol of convenience in this case is acceptable because it's reasonable to believe that there is no systematic difference between the symbol and the population. But if you think about the symbol of collecting GPA, that symbol of convenience is not acceptable because there is a systematic difference between the symbol and the population. Just like if your symbol is all, like if your symbol consists of all smart people, so their GPA is for sure higher than other people. So the average of your symbol cannot be the best representation for the whole population. So that is about symbol of convenience. Now we go to the third type of sampling, stratified symbol. Here's a situation. A company has 10,000 employees, of whom 800 are full-time, 20 are part-time. The company wants to survey 50 employees about their opinions regarding benefits. Attitude toward benefits may differ considerably between full-time and part-time employees. So in this situation, if you are assuming you are the investigator and you want to collect a sample of 50 employees, if you should run random sample, there might be a case that you collect 50 employees of more people who work in part-time than people who work in full-time. So your symbol cannot be the best representation to answer the question, what is the attitude towards the benefits? because part-time employees' opinion might be different from the full-time employees. For example, full-time employees normally receive more benefits compared to part-time employees. So, solution: if a simple random sample is drawn, it is possible that the sample will contain only a few part-time employees and their attitudes will not be well represented. So simple random sample is not the best fit here. And in that case, we think about using trader. So here, because we have two type employees, full-time and part-time. So we are going to use two trader. The population of the group of people who work full-time is one trader, and the group of people who work in part-time is another trader. So in this case, for each trader, each group, we are going to draw a simple random sample. So here we are going to draw a sample of 25 people who work in part-time and 25 people who work in full-time randomly, and then put them together to make up a sample of 50 employees. So that's how stratified sample works. And in this method guarantees that both full-time and part-time employees will be well represented. So that is about stratified sample. The idea is using trader. Definition: in stratified sampling, the population is divided into groups called trader, where the members of each trader are similar in some way. For example, in the last example, in the trader of people who work in part-time, they have one similarity, that is they are all working part-time. In the group of people who work in full-time, they have one similarity, that is they are all working full-time. So a simple random sample is drawn from each trader and then combined together. That is the idea of stratified sample. The advantage of stratified sample is stratified sampling is useful when the trader differ from one another, but the individuals within a trader tend to be alike. So that is about stratified sample. Now we go to the sampling methods number 4, cluster sampling. The idea of cluster sampling is pretty much similar to stratified sampling. They use in cluster. Let's look at this example. To estimate the unemployment rate in a county, a government agency draws a simple random sample of households in the county. Someone visits its household and asks how many adults live in the household and how many of them are unemployed. So in this situation, the county has maybe 1,000 household family. So it's like the investigator is not going to collect all of these 1,000 households. They just choose some household. That means they choose some cluster, and its cluster is household. All of the members in that household will be collected. So the solution in this situation is the cluster are the group of adults in each of the household in the county. And this is a cluster sample because a simple random sample of cluster. Here is the difference with the simple random sample. In cluster sampling, we run a simple random sample of clusters. And then in each cluster, every individual in each cluster will be selected. So, since cluster sampling and stratified sampling are both defined based on the methods of group dividing, many times people tend to be confused between the two types of sampling. So here is the difference and the common things about cluster sampling and stratified sampling. one common thing is both cluster sampling and stratified sampling, the population is divided into groups. However, in stratified sampling, a single random sample is chosen from each group, that means each trader, and then put them together, combine them together. And usually in stratified sampling, the groups are divided by level of education and opinions. In cluster sampling, a random sample of groups is chosen, and every member of chosen group is sampled. So, and usually the group is divided by location. So that is the difference between cluster sampling and stratified sampling. Now we go to the sampling methods number 5, which is systematic sample. The idea of systematic sample is just make it systematic. For example, imagine working alongside a line of people and choosing every third one. That would be produced a systematic sample. So in a systematic sample, the population items are ordered. This is the difference. The unique thing of systematic sample that is we care about the order. It is decided how frequently to sample items. For example, one could sample every third item, or every fifth item, or every 100th item. So in systematic sample, we basically care about the orders. Here's another sample. Automobiles are coming off an assembly line. It is decided to draw a systematic sample for a detailed check of the steering systems. The starting point will be the third car, and then every fifth car after that will be sampled. So which cars will be sampled? In this case, we start with the car number 3 and then count by 5 to determine which car will be sampled. So the sample will consist of cars number 3, 8, 13, 18, 23, 28, and so on. So that is an example of systematic sample. Now we go to the last one, voluntary free response sample. Voluntary free response samples are usually used by media to try to engage the audience. And the idea is just make it optional and voluntary. Like sometimes you try to collect the opinions, collect the ideas, feedback from people. Sometimes people will deny to, will not accept to respond to your question. So that's why we need a sample that is free for people to choose whether they answer or not answer. Here's an example. A news commentator will invite people to twist an opinion, or a radio announcer will invite people to call the station to say what they think. So in this case, people who go to trouble to volunteer an opinion tend to have stronger opinions than is typical of the population. And people with negative opinions are often more likely to volunteer their responses than those with positive opinions. Like suppose you go to a supermarket, and then if you have some negative feeling, you will go the chain that you go to the customer service to complain is higher than you have nothing to complain. So usually people with negative opinions are more likely to volunteer their opinions, their responses. So that is everything about sampling. I have covered 6 basic methods of sampling. So now I would like to do some check your understanding. Determine the types of sampling in the following situation. Example 1. Draw a sample of 8 animals by drawing a simple random sample of 2 animals from each group. What kind of sample is this? So here you see, like, we have 8 groups of animals, and in each group we will run a simple random sample of 2 animals. So this is a stratified sample because we have a trader, and in each trader we run a simple random sample of 2, animals. So the answer is 35 symbols. 8 traders are 8 groups of symbols. And in each tradum, we collect 2 animals, and then we combine them all together to have a symbol of 16 animals. So that is an example of 35 symbol. Now look at the second situation. Draw a random symbol of 2 groups of animals from the 4 groups and construct a symbol of 20 animals by including all of the animal in the symbol groups. What kind of symbol is this? So here we will draw the group first, like we make random symbol of 2 cluster, right? 2 cluster from 4 cluster. And from each cluster collectors, we will collect all of the animal from that cluster to make up a symbol of 20 animals. So this is an example of cluster. So cluster symbol is the answer. Each group is a cluster. Situation 3. A college faculty consists of 400 men and 250 women. The college administration wants to draw a symbol of 65 faculty members to ask their opinion about a new parking fee. They draw a random symbol of 40 men and another random symbol of 25 women, and then combine them all together to make up a symbol of 65. So this is another example of 35 because the opinions are different between men and women. That's why we have 2 traders. One tradum is the group of 400 men, and the other tradum is the group of 250 women. In each tradum, we collect a random symbol. In the tradum of men, we collect a random symbol of 40. And in the random symbol, in the tradum of women, we collect another random symbol of 25 women. So that is an example, another example of 35 symbol. So opinions might be different from 2 groups, men and women. 2 groups are the 2 traders. Situation number 4. A retailer assembled 25 receipts from the past week by numbering all the receipts, generating 25 random numbers, and sampling the receipt that correspond to these numbers. So in this case, you see that they use a computer to generate 25 random phone numbers, generate 25 random numbers of the receipts, and then collect the 25 receipts. So this is guaranteed. This sampling method guarantees the randomness, and the chance of getting any number would be equally likely to be equal, and the chance of getting any group of 25 random number would be equally likely to be chosen. So this is an example of random symbol. Situation number 5. A poster obtains a list of all the residential addresses in a certain town and uses a computer random number generator to choose 150 of them. The poster visits each of the 150 households and interviews all the adults in each household about their television viewing habits. So here first they generate a random symbol of 150 clusters. And in each cluster, each household, they go and collect the information of all the adults in the household. So this is an example of cluster sampling. There are 150 clusters, and each cluster consists of all family member adults in that household. So that is situation 5. Now we go to the last situation. All the customer who enter a store on a particular day was given a survey to fill out concerning their opinions of the service at the store. So you see all the customer who enter a store on a particular day. So this is an example of convenient symbol because we make it very convenient. Anyone who come to the store will be asked about their opinions. Sometimes some people might also consider this symbol as voluntary free response because the customer might are free to choose whether they respond or not. So it depends. Like sometimes this situation is also considered to be a voluntary free response symbol. Next, situation 6. Every third day, a computer network administrator analyzes the company network logs to check for signs of the computer viruses. So here, there's one thing you have to pay attention. Every third day, so we care about the order, which is collect only the third day of the month. So this is a symbol of systematics, a systematic symbol. So that's all for today. Thank you so much for watching, and I hope you guys will follow up with me for the next video about types of data. And thank you so much. See you next time. Goodbye.